Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Josh Jordan. Today, we're going to talk about Nomad. Nomad is one of our lesser known tools, but has a strong following of past users. People usually really love Nomad once they start using it, so we're excited to share more about it with you today. Josh is going to show you how you can leverage Nomad's architecture to simplify your infrastructure complexities, ultimately allowing you to optimize the where and the how of applications running in your fleet. I also want to note that this Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be about 20 minutes and then we'll allow up to 30 minutes afterward for questions. Please remember to go ahead and submit your questions throughout the demo through the GoToWebinar portal, and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, Josh.
Thank you, Amanda. So it's nice to meet everyone. I guess I do want to dive into this quickly because the whole 20-minute part, I'm going to have to try to really actually pull that off. But the goal today is to really talk about Nomad, and so this is going to be a combination of a little bit of informative information, kind of dump on you, but then it's also going to be the actual live demo. So let's kind of get into it. The reality is, the guide is that tooling is essential when building and distributing application systems. We know this. Practitioner concerns typically vary from one system to the next. So the project may change, the context may change. And so we all know that tool selection is really, really important and typically influenced by the problem context. What I want to do with this kind of talk track, and I may do more under the same type of principle, which is to kind of isolate what are the reasons you chose the tool in the first place, right? What are the concerns that kind of draw you to a tool choice as opposed to conforming a problem to a tool? It's kind of a different approach, kind of almost backwards in a way, but I think it'll reveal itself more as we move forward. So with that said, what context makes sense for Nomad? And obviously, I work for HashiCorp, so there's bias here, certainly, and we'll cover that first. But then there's also a lot of function that Nomad provides that Amanda touched on to begin with that I think that we can leverage depending on the context that we're in. We'll start with the bias part. Obviously, the Hashi stack, there's the 4 essential elements. We've got to provision infrastructure, we've got to secure that infrastructure, we got to run applications on that infrastructure, and we hopefully can connect everything in between along the way. Now, Nomad and what we were focused on really is in the developmental component, right? We want to run applications. And so what is Nomad? Nomad is an orchestration tool, and it's actually concerned with service architectures, and it provides configuration and coordination and management of those architectures. And it actually allows you to run applications easily, primarily because of one of its feature sets regarding, containerized or non-containerized type of applications. And so if somebody is using Nomad, like we already have established that, yes, they have chosen Nomad as the tool, I think it's nice to abstract the concerns. Why? Why did you choose Nomad? What would be one of the reasons? One of those reasons is high availability. And I think the question that people typically ask when they use Nomad is, how do we want to leverage redundancy? Not just have high availability, not just achieve high availability. How do we leverage it? How do we leverage it to our advantage for some business prop? And really, I think that starts with high availability in the first place, right? So the reason we even have high availability is because we have essentially the same application or suite of services spread across our fleet. And we do that because if any of them die, or if a large number of them die, we actually maintain the ability to service the users. That's kind of the point of it. And so really, if you're using Nomad and you want to take advantage of its high availability placement components, like you would with a lot of other schedulers as well, what you're really trying to take advantage of is, all right, we're going to take this same setup, but now we're going to deploy all of our services into containers. And now, even if the same 3 applications die across 2 boxes, I still have high availability across my entire fleet, right? So that's kind of one of the visual value props of even moving to like a containerized workflow anyway. And actually, because of this, what ends up happening is you can achieve the same high availability footprint with 1 less VM. And Nomad actually also provides configuration options. It's got like the service where it just finds any service that it wants to throw out. It's got the system where it basically deploys the exact same service across everything that's available, all the clients that are available. And then that last one we just saw there is the batch, where it just kind of finds a place to run some job ephemerally and then kills it afterwards. But Nomad also provides us the ability to extend this across regions with WAN. So like basically we can leverage console to communicate between regions and basically allow for service discovery and deployments across our regions and the data centers housed within. And so another thing or concern that might be present when we're using Nomad, like again, the person has chosen Nomad, and so we want to kind of abstract why. Well, what was the concern that made you choose Nomad? And I think resource utilization is a big one, like a bin packing. So the idea is, how do we get the most out of the infrastructure that we deploy? And if we look at this, every VM has a cost, every compute has a cost. And we could deploy containers and services across our VMs. In this case, we have 3. But if this is what our footprint looks like, why not tail it back and actually fill up the VMs with the services? I still have 2 instances, so in a sense, I have high availability this way. But if I have a fleet of services, I'm actually making the most out of my box, which means over time I can then follow the same protocol and not overspend or over provision too early or too soon. And that's kind of one of the value props of bin packing. And then one of the third primary concerns, and to me, the big driver of why I think somebody has elected or an organization has elected to use Nomad is typically because they have some hybrid ecosystem. When I say a hybrid ecosystem, they may have containers or traditional applications. And so the idea is really, the question we ask is, how do we build for the future and drive business value in the present? And I think really this single picture here kind of makes sense of that, in my opinion, right? So the idea is, you have containers, and you're not gonna use containers for the most part. Most of these companies are not even really using containers, and so we ask why. Well, a lot of times, like, containerized workloads don't really fall in legacy. So the legacy conversation's there. It's like, yeah, I have some legacy app, and to rewrite it for containers would be a nightmare. So we just don't even. It just kind of lives in the dungeon of our organization somewhere. And so that's all well and good, but if that's the norm, and even after the orchestration paradigm has kind of taken over our industry, and we're still having like limited containerized usage, then it would kind of be nice to have an orchestration tool that can run any type of application, and basically as if it were a service in a container. And that's really what Nomad allows you to do. You can run binaries, like in our demo example today. I'm writing a Go binary as my API layer, and then I have Nginx in a container. So I'm literally running both. I'm running like a Docker container, and then I'm also running a Go binary just to expedite my delivery of whatever application I'm doing. And to be quite honest, we typically characterize legacy as like a non-containerized application, but I don't really think there's anything legacy about running a bunch of Go binaries. To be honest, like, I'm just leveraging the language's power. I'm leveraging the ability to compile and port to a various suite of platforms and ecosystems and run it as a binary without, absent of Go as my environment runtime, right? Like, there's nothing legacy about that. But at the same time, I understand most of the draw is going to be on the legacy side, but it really, Nomad just enables you to run multiple types of applications or services inside of your overall ecosystem. And that's a big value add. And then there's also, what are the other reasons you're probably using Nomad? And those are pretty obvious, right? You're probably using console already. You probably leverage console template a lot. You may even use Vault. I'm not going to use Vault for this demo, but I am using console and console template. And so Nomad has first class. I mean, they treat console and console template as first class citizens. So I can leverage console template to write out any type of file in case my HTML is actually templatized, and leverages console template to pull some environment variables. And then I'm also using console template with my Nginx load balancer, so that I can actually pull the IP addresses of the services the console makes available as they become available. Another reason you might be using Nomad is because you're leveraging native cloud services effectively. You're using GCP, AWS, Azure, or any of the other myriad of cloud providers for storage or some of the services that they're using. So you're not necessarily, maybe you're not managing your own database. Maybe you don't care because you feel that the big guys have already solved that problem. So you're doing that. And because you're saving money on compute for not over provisioning, you don't mind spending for storage because it's good use of your money. And so these are typically the spaces where I see Nomad as a concerned choice based off of a concern that may not necessarily deal directly to the functionality it provides, but certainly would be a deciding factor. Does anybody have any questions before we kind of move into the ecosystem or the actual demo that I have?
So far, Josh, I think we're good.
Okay, cool. So let's do that. So what we're going to build today is we're going to build an application that it's a service mesh, and it is highly available. And so what that looks like is it's going to be, well, let's just actually go here. So you can see here I have my services. Console's already been pre-configured. When I deployed my cluster, which is 9 servers total, I have 3 console servers. I have 6 Nomad servers. 3 are clients and 3 are the servers that actually issue the jobs out. So the way this works, though, is my 3 clients also have Nginx and console template on them, and which means that as console finds a service that we deploy, console is going to write that IP address, internal, the local network IP address, to all 3 of those clients. And I'm basically going to remove the need to have a north-south load balancer. Now, I'm not saying this works for your production environment, but it's pretty powerful to have Nomad and console to create just a drop-in service mesh. Like literally, I could point my A records to all 3 of these clients and just let the internet figure out how close somebody is. Like that, to me, is super powerful. So it's also a good place to talk about placement and bin packing. So I think it just gives us a good environment to kind of work with that. So you can see here, we have console. I have my Nomad services are up, and these are all underlying services related to Nomad. And then on the other side, I actually have my Nomad UI that we'll be referencing as well. You'll see the jobs populate, and then we'll be able to look at the clients and servers and kind of see what they're all about. To begin with, I think it's valuable for us to kind of look at the code and just kind of see what's going on there, right? The first thing we're going to provision is a web server. And you can see here, this is my job specification. And in Nomad, the job specification is your, this is your declaration, your manifest, so to speak. So the idea here is I'm going to run this in DC1. This is going to be a service type. Remember, we have 2 other types. There's a batch type and a system type. If you were going to deploy some type of database or something, it probably makes sense to do a system type. System just says, hey, this same thing, this same unit of work, the same group has to be on all 3 of the clients that I provision. But in this case, I'm doing service, which means I don't care where it's at. Just throw it wherever. I just do not care. Just send it. And so the idea is that we're going to run 15 of these, and that's probably extremely excessive for a web server. But just to prove a point with bin packing and like leveraging resource utilization, that's what we're going to do. And so you can see here, I'm running a template. This template is leveraging console template to write some variables that Nomad has access to, such as the region that it's in, the name, the number of cores that is on the box, and the total compute that's available, as well as where the IP address is in the port, and that's the internal Nomad IP address and port. And so I could have wrapped all this HTML up into a file reference, and probably would have been nicer and cleaner. I'll probably do that in the README and the repo before we submit it tomorrow, but the idea is still the same. I can reference a template here to take advantage of Nomad's integration with console template. You can see here I'm going to run this job in a Docker container. Now, Docker has to live on the client, so that's something to talk about now, actually. It's important. So on my client machines, Docker is on each one of them. So is the Go binary that I'm going to run as my API. So is Nginx. And so is console template. These are on all 3 of my machines for this particular configuration to work as intended. But regardless, whatever application, whether it's a binary, if you're running a binary, the binary needs to live on the client where it's going to run. And in case of Docker, if I'm pulling an image, that's fine, but Docker needs to be on the machines. So you can see here I'm running in a small footprint container, Alpine Nginx, and I'm just leveraging the HTML template that I wrote from this destination, and I'm just going to leverage that for my Nginx's HTML path. You see here I've set some tags, and I've done a check so that we can make sure that it's working. On the other side, we have our Go API. Go is not running in a Docker container. Go is just a binary. That's all it is, and it exists on all 3 of my clients. I'm also running it as a service, and I, again, am going to deploy 15 of these and just deploy them out across my fleet. I do not care where it lands. The reality is, again, I'm using templating again. The reason I'm doing this is because I'm creating a JSON file that I'm going to then serve requests from the web server on. So this template file just says, hey, collect some stats about this particular job, and I want you to send it back when somebody requests it. And so this is an example of native console template integration and being able to leverage that if you're using Nomad. And so really just going to respond with this particular file. I'm setting it up on HTTP port, and then I have a check as well. Again, the tags. One thing, I'm also setting an environment variable for a port. My Go application expects to receive a port. In this case, I don't get to take advantage of Docker's mapping. Like, Docker will map internal ports to whatever external Nomad port needs to expose. In this case, I actually get that from Nomad, and I just pass it to my application, and it works just as well. So that's one of the things to be aware of if you're going to use a non-containerized type of exec script, and that's what we're doing here, just to clarify that. And so I think it's kind of good. Let's just go ahead and let's run it. Okay, so what we're going to do is we're going to check. We're going to do Nomad job plan. And we're going to do doc agent demo, configuration jobs, and we're going to run go first. You're going to see that it has, actually, let's pull this up so we can actually see more. So the idea here is it says, okay, I'm planning. If you're familiar with Terraform, you already know this kind of workflow process. I'm planning 15, I'm going to create, cool, that's great. Everything's good, let's go ahead and do it. Fine, run it. Now you can see it's actually created the allocations. Now this takes a second to come up, but we actually can go look at it, and you can see that Go API is already starting. This means it's pending, so it's already starting to run. We can actually look at the client and see where it's where it's distributed, and we can actually watch as these are pending, and then they actually kind of come up. So again, this is us deploying the job file to the Nomad servers to then create allocations and basically map those job specifications to the clients to actually deploy the infrastructure. You can see that they're running. Are all of them running? Not all of them are running. Yes, looks like all of them are running now. Okay, that's good. So now that we've done that, let's go ahead and do our web server. We'll follow the same, really the same workflow and specification, except this time we're going to plan it first. Again, 15 to create. It's brand new, so it doesn't really care. It's just letting us know that everything's good. So let's run that. And you'll see it's created allocations for 15. Now this is 30 containers total, right? Spread out across 3 machines. And so that's what 30 services spread out across 3 machines. And that's what we've deployed. Now, one thing I wanted to bring your attention to is that you can see the web server, obviously the Nginx web server doesn't take long to run at all. But now supposedly we have everything available, but let's look at our clients. So on client 1, you can see that there's a single instance of the web server, and then there's a few more instances of the API. And then on client 2, you can see that there's more instances of the web server and a few more instances of the API. So again, this is placement in action, right? Like I don't care where this is at. And the reason I just want it to be somewhere, and I want it to be available, highly available to me without caring how it is out there. And the reason I don't have to care is because of console. Console handles all my service discovery for me. So the reality is when I have console in here, I'm basically depending on console to expose all of my services so that I can then access them from my load balancers that live on my Nomad clients. And so let's go look at what that looks like. We can actually just take a peek into that file right away. I actually put a little script together. So I'll go to doc agent, scripts, inspect. What is it called? Yes, inspect remote file. I need to actually call it. And any thing that I'm leveraging here is going to be available in the repo for you to leverage as well, or not. It's totally up to you. So we want to go to Nomad client 0, and we want to actually look at the Nginx file, comp.d defaults. If you look in here, you can see all of the IP addresses, right? This is load balancing without north and south, like web-based or native load balancers in action, right? I am essentially saying every single one of these web apps that I've deployed, I want you to make it available so that I can get to it, and I want you to make the API available so that I can get to it as well. And I'm going to map these to very simple locations so that I can get to them in wherever they are. It does not matter. I totally do not have to care about where they are. And we can actually see that in action. We just have to go open the files. So you can see here, this is Nomad client 1. And actually, well, that's fine. So you can see we have Nomad Client 1. The thing to pay attention to in this case is notice up here, we've got the data center information that I mapped out earlier. This is what, again, was pulled in from console template. You can see the client node that I'm on. You can see the footprint, which is how many cores are running on each one of these boxes, and what the network, the internal network IP is. Now watch this. Watch this all change, right? Hold on a second. There it goes. Port changes. I may have to do a ton of these requests to get it to work fast enough, but the reality is you can see that changing. It's not only changing the box that it's pointing to, it's changing the client that it's actually pulling the container off of. We have effectively got high availability just by setting up console and being able to have those IP addresses available to us so that we can navigate directly to the containers and not really care about where they are. We could still get to the same services. The same thing also applies, and actually, to send that home, let's do this. Show you that it's a different IP. You can see this is the same for all of them, right? This is all three clients, totally different IP address. As a matter of fact, that is not the IP address of one. Like this is 0, and yet it's still hitting 1 to get the data, right? So the idea is that you can change it, and it'll hit whichever one is available. And we have so many instances available, it would take me a lot of clicking and refreshing to actually hit all of them, but I think you get the point. We'll open 0 as well. And again, same thing applies. I'm still refreshing, and based on the load balancing effort, Nginx is handing me off to whatever container is going to take the request. But the same thing actually applies for the API, right? Now, the thing about the API is that we're running so many instances of Go API, and we're also running a lot of routines. It actually may not refresh in the time I'm clicking this. I'm clicking this rapidly fast, but it's not doing it. So in preparation for that and knowing that would probably happen, we can do, hold on a second. Hold on a second. Let me pull it up real quick. Show you this real fast. Here we go. All right, so hold on a second. Let me pull this up. This is my API. Watch that port change. This is the API call, right? This is the Go binary that is actually doing all the requesting for me. So like I'm actually pulling a container from a totally different client, from a totally different port, from a different container on one of these nodes. And again, I may have to press this. I would have to probably write some like, flooding script to actually get it to hit client 2 at some point. But the reality is that it's basically ping-ponging off of what is available, highly available on our client nodes that we have, and we just bin pack it with all the services that we need, make them all available, and we don't really have to care about over provisioning. We can manage our resource allocation a little bit more effectively. So if we wanted to, any questions up to this point? I've kind of talked a lot.
Josh, we have a few so far. Do you want to go ahead and finish the demo or just kind of go back and forth?
The only thing I was going to show is like how we can inspect. Let me just do that real quick, and then we'll take those questions. That's
okay.
That's great. I'm almost done. So the reality is like if we wanted to inspect what our allocations look like, I could look at my status, say I'm going to look at the Go API, right? It's going to come back with all the allocations that I have. All right. Well, I can take the allocation ID. And I can then go, this is the part where I say, because I don't have to worry about my topology and high availability anymore. So now I'm more concerned with like resource utilization. I'm trying not to have to bin pack that next VM, right? So this is pretty much my day now. This is what I'm doing. I'm essentially going Nomad, allocation status, and I'm pulling stats, and then I'm going to pull some allocation ID, and I'm going to see how much are you actually using? Not very much. So I should probably make a change to my API to not use defaults that are not effective. So the idea here, CPU, let's do anything's fine. Let's just do 20. That's fine. Memory, don't think we exceeded that either. Yeah, we're really small on both of those footprints. So the idea is that now I've done this, I've made the change. So, and actually, let's provision a few more. Let's do 30 of these things. All right, so now if I go Nomad plan, and like I was doing, demo, configurations, jobs, simple web API. Now it's going to say, hey, we've got your new changes. You want to create some more? Awesome, go ahead and do that. So now we're going to do that. And so again, this is kind of like where you can leverage the fact that you don't have to worry about your topology and routing to your infrastructure to make better use of bin packing, stuff that's provided with Nomad to help you out. Now I can still show stuff I need to, but I think it's a good place to start taking questions and see where the conversation goes.
Perfect, Josh. Okay, thank you. Great demo. And we do have a few questions, so anyone that has questions, please go ahead and submit them through the portal, or if as we're asking questions, that sparks another one, go ahead and submit those and we'll get to them. So first question, Josh, someone's wondering, does Nomad support rebalancing of containers throughout nodes?
So when you say rebalancing, are we talking about like scheduling deployments, like some type of like upgrading type of pattern?
You know, that's all they said. So
okay. So if rebalancing means I want to make sure that the container looks the way it's supposed to follow a certain specification, yes, we have constraints. You can set constraints on how it can be deployed, what's the memory footprint allowed, and you can actually set constraints at the group level, the task level, and lower actually. So yes, you can set constraints on how you provision. If the question is, does it do like rollout deploys? It does do canaries, so you can do those types of things as well. And there's documentation on all of this online.
Okay, cool. And if the person who asked that question does want further clarification, just submit in the portal. We can come back to it. Okay, so next question. Someone's wondering, what happens to Nomad clients if servers are unavailable for a period of time and then they come back after a while?
So if Nomad, like if a Nomad server dies, you can bring it back online and it'll sync up with the other Nomad servers and you're good to go.
Awesome. Okay. And then someone's wondering, can you put limits on the amount of memory resources used per job with Nomad?
Yes. So what's happening here is when I assign this job, I'm saying that this resource only has, you know, the last thing I did, right? I actually inspected with allocations to see how much are these allocations taking. Now, to know exactly how much they're taking, you'd probably want to, you know, leverage the API and pull in the data to kind of make a general average type of guesstimate on that. But I just, for this demo, I could just take the first allocation and say that was way too big of a footprint, and I set it here in the job in the resources section.
Okay, thank you. So now someone's wondering, so is there a way to limit teams to run jobs only on certain clients within the open source version of Nomad?
No, we're talking about, so there's enterprise features. I wasn't going to talk about enterprise features, but might as well. So namespaces.
Yeah, just run through kind of the difference of open source and enterprise.
Yeah. So like the namespace. So really, the enterprise offerings that you're going to take most advantage of is one, namespaces. Two is resource quotas. So this actually goes back to the question that was just asked. If you need a more elaborate type of specification on the amount of resources that a deployment will take up, right? You're in a big organization. You know, you got people that are provisioning, leveraging their orchestration with Nomad all the time, and you may want to have like constraints on just generally, if somebody were to provision something on a weekend and I don't work on the weekends, I want to know that it's never going to exceed a certain amount, right? Or my cluster will never have infrastructure of job type web server that ever takes up 2 cores. Like that, that's just, no, it's not going to, you know, those types of declarations you can make with resource quotas. The namespaces is, you know, very much like I can isolate environments inside my data centers and kind of segment my data centers per region. And then you can also establish resource quotas for namespaces as well. So that would be a way to kind of assign permissions. And then there's Sentinel. And Sentinel is, you know, it's across all of our products at the enterprise level, but Sentinel kind of gives you that more granular control on how a job would be declared. We can, and I can, again, all this stuff is documented online, but those are essentially, those types of governance level constraints are at the enterprise level most of them.
Okay, awesome, thanks. And then to quick jump back, Josh, to that original question where someone had said, does Nomad support rebalancing of container throughout nodes? So they wrote back in, they were saying what they mean is that if, say, some nodes go down and new ones come up, will the containers be spread out evenly?
Oh, I see what you're saying. Right. So if I have 5 in client 1 as an example, and in client 2 I only have 2, and then 3 go down in 5. So yes, you can reschedule. You can have like a rescheduling block where it's like, when it dies, what do you do? What is the action Nomad takes? It really depends on your declaration, right? If you're doing a service type declaration, you can specify where it's going to go. Like you can use a constraint to say, yes, it's going to go here, it's going to go here. And if something fails and it picks up a new job to redeploy, it's going to read that constraint. So in that case, yes. But also, you can take into account that if you really need something to run all the time on all 3 of your available clients, then you just use a system job. And system
Okay.
will always spread it out across that fleet.
Okay, thank you for further clarifying. Okay, so next question, a common question that comes up with Nomad. Someone's wondering, how does it differ from Kubernetes and what are some of the advantages for Nomad?
Okay, we'll start with differences with Kubernetes. In my opinion, it's more flexible because it's not trying to solve all the problems of the world, and it's not being standardized on. And because of that, it can be more flexible, which I think is a huge value add for somebody like me. I prefer to just do things and get work done, as opposed to trying to get YAML manifested to do what I need them to do. But anyway, that's one of the general benefits. I just feel like it's a lighter, more flexible tool. It doesn't pigeonhole you into a certain way of doing things. It's also configuration based, right? So it's a fantastic stepping stone. Even Kelsey Hightower's talked about this. Nomad is a great tool to use moving into, like, if the Kubernetes is the end goal, then use Nomad first. If you have zero understanding of how orchestration works or configuration with orchestration, use Nomad first. You won't bang your head against the wall as much. And then on another thing I think that Nomad's really valuable with is, the obvious one is the fact that it doesn't have to be dependent on containers. Right? Like, yes, it's wrapping them up in native containerized technology on the operating system. I'm not saying that's not happening, but you didn't have to write it for a container. You didn't have to train all your people to like figure out how to do YAML and all this type of stuff to actually deploy your application infrastructure. You just wrote your binary that you've always had and drives business value today. So I do think Nomad gives you a little bit more ability to get more business value as well as prepare for the roads ahead. And then finally, to kind of sum all that up, like, it's not really a competition. It's not really that one does anything better than the other. I think they could work alongside each other very well. Like, Kubernetes is fantastic for, especially when we talk about like persistent storage. Kubernetes is fantastic with that. Their rollout strategy is really, really good too. Like, and they have a lot. There's a lot of benefits of using a Kubernetes type of infrastructure. But Nomad also has its place as well alongside Kubernetes if that's the strategy you want, or as a replacement for it if your workloads like demand that that's what you want. Like, if you don't have like the requirements that you need to use just Kubernetes all the time, use Nomad. It's more flexible.
Mm-hmm. Yeah, and Josh, you see out in the field with customers, like with the enterprise version, Nomads can scale pretty much infinitely.
Yeah. So there's a lot of financial institutions that use Nomad to run basically high intensity workloads for like computation, right? Like, if you're in AI and you're in the AI space, and let's be honest, you're in the AI space, you're spinning up containers, you're maxing out the boxes, you're basically transferring all the data that's as your output, and you're making some assumptions for your cognitive plane of whatever AI you're running. And whether it's a financial prediction or whatever, it doesn't matter. Like, you're running these high intensity workloads, you need to be able to leverage containers and effective orchestration. Nomad is really hot in that area, but again, because of the flexibility. I think another, to add to that a little bit, is I also see, I get a lot of customers that want to, or prospects even, that want to consider Nomad they're moving more towards native services. Like I mentioned this earlier, like they don't really care about managing their own databases. Like they feel that the cloud providers have already solved that problem. And so they don't really care about how elegantly Nomad handles persistent storage. They don't care because they're already making API calls for their storage engine anyway. And they do like the fact that they can run batch jobs as well as not have to worry about placement of containerized applications for all their workload types.
Yeah. Okay, awesome. Thank you. Okay, and then just two more questions, unless anyone else has a question they want to submit, go ahead and do that now. So the first question, Josh, someone's wondering, again, kind of going back to other tools, are there any advantages or disadvantages of using Vagrant, HashiCorp Vagrant, instead of Docker with Nomad?
So actually, I haven't come across any advantages or disadvantages other than the fact that, Docker is a native driver. So I guess it's important to talk about how Nomad leverages the drivers. So the drivers I used today were Docker, and then I use the exec driver, which is what allows me to just run a binary. But then there's some others. There's a raw exec, which is like you don't necessarily want to isolate the environment, you just want to run it on the box. You can do that. We kind of disable that by default. And then there's other driver plugins coming down the road. I don't know. I want to say no because I haven't heard of anything. But to me, there's no like direct. There's just the Docker driver. So I would feel that like I would need to follow up on that and find out what the nuances are within.
Okay, thank you. Okay, and then final question. Someone's just wondering, in the Canary deployments, can we establish in Nomad the amount of traffic through blue or green deployments?
So, you're asking an Envoy question. So the idea is, I don't know. Actually, I would have to follow up on that. I don't think we do that. I think that's more of a like. Is that a routing question, or is that like a? I guess I need clarification. Is that a routing question, or is that like a percentage of the containers that I'm going to deploy given a Canary type of consideration? That's a clarifying question. Yeah, I need to know what you're asking, routing or not.
Yeah, so if the person who asked that, if they want to quick type in some clarification. But yeah, it looks like, a routing question, I think, Josh.
Okay. So routing is, in my case, so Nomad's not routing anything in the sense that at that level, like if you're talking about layer 7 routing where I want to manage, like I want 30% of my workloads to go here, I'm not doing that. I would use Nginx to pull that off to actually manage the allocations to my underlying containers or the server or services that I've exposed. Regarding the specifications of Canary deployments, I'm not aware. I would have to follow up on if that's something that's achievable.
Yeah. Okay. Awesome. That was the last question, Josh. So thank you for getting through all of those. And as I mentioned to everyone at the beginning, this Hangout was recorded, and we will make the recording available on our website after processing. I will send an email out to everyone who registered with that recording link. Also, if you liked what you heard today and want to start exploring Nomad a bit more, I encourage you to check out our new Learn site. You can find it at learn.hashicorp.com/nomad, or just go to our homepage and click on Learn in the toolbar. You'll go ahead and find it there. So I hope you all enjoyed today's Hangout and have a better understanding of Nomad's full capabilities. Thanks for hanging out with us today, and a big thank you to Josh for his time presenting. That wraps things up for us. So have a great rest of your day, everyone. Goodbye.